Hi everyone, so this is lesson 4. It's a 2024 version of the A2 probability pack. This is first bit, just do yourself and you can just check with the teacher. I should just copy what I write down. Right, so then it starts on these two, so there are 1, 2, 4 questions in total. So given that, so we've got that information, so let's use the fact that we know that A and B divided by A, so we've got that actually, let's put this down. So B, given that A, will be B and A and B, same as, but divided by A, has to be divided by given that. So my 0.5 is the probability of A and B divided by 0.4. So if I go up and times it up, that gives me 0.2. That's part A done. Part B, A or B. So that'll be A plus B minus A and B. Everything. There's nothing else apart from A or B in the whole world. So A given that B, it's always divided by given that. So A and B we've worked out as 0.2. B is 0.8, so that's going to be a quarter, isn't it? There we go. I'm choosing that. So look at the next bit then. So question 2. So we want A given that bit. So always divide by the given that. 0.3 over 0.7, so 3/7. And B given A. So this is just to show you that it's not the same. I'll put A and B, it is actually B and A if you follow it through, but A and B is the same. Divided by A. It's going to be 3/5, 0.6. So the big thing here is just stressing the fact that they're not the same. Right. They're not the same. Right then. So look at question 3. So 3 events A, B, and C. So you've got that. It says A and C are mutually exclusive and B and C are independent. Right, okay. So A and C are mutually exclusive. So if we're going to do a Venn diagram, we wouldn't want all 3 of them crossing over. A and C can't cross over. So let's do it like that. Right, so what do we know? So A and B is 0.3. So we know that little bit in there, 0.3. So that must mean that that's 0.1. We can't do the rest of B because the whole crescent is 0.4. We need to know what B and C are. Oh, it's asking us to find out what B and C is. That's nice of us. So B and C. So it tells you that B and C are independent. So if that's the case, it's B times C. So B and C is 0.28. So if B is 0.7 and I've used up 0.58, that bit there must be 0.12. If C is 0.3 and I've used up 0.28, that must be 0.02. If I add all them bits together, it leaves me 0.08 on outside. Right, so that might help us if we need some bits later. So B, the probability of B given that C. So B and C over C. So B and C is 0.28. C is 0.4. That's going to give us 0.7. Let's pack. Let's have a look at C. So A, given that not B, so that's going to be A and not B. So A and not B is the 0.1 there. We know that B is 0.7, so not B is 0.3. So I've got a third for that one. Right, let's have a look at D then. I think D is going to be quite an interesting one. So it's B and C. Given that, it's not A. So I'll have to be a little bit messy with this. I can put the formula over here for it. So that'll be B and C and not A over not A. So B and C and not A will be, so B and C, not A, is that part. So that's going to be 0.42. We don't know what. Not A. Oh, hang on. I was doing B or C. B and C is the 0.28. And not A is everything other than the A. So it's just 0.28. And then not A would be 0.6. Which is 7/15. That's messy, that one. So we change colour and try and make sure you're happy with a line of 0.28. So B and C is 0.28, and it's taken from everything outside of A. So it can only be the 0.28 that we're using. It's a bit messy, that one. Sorry about it. You might want in class, you just might want that explaining again. Right, last question. So it says it's known that 2% of the population in a country are affected by popular disease. So 2%, 0.0. So not affected by the disease, 0.98. So I've done that. A diagnostic test for detecting the disease tests 97% of the time when they have the disease. So it tests positive 0.97. So that this bit here is the disease. This bit here is the test. So that'd be 0.03. Not positive, 0.03. Positive, not positive. And then it says, so hang on, let me get the wording right. So diagnostic test for detecting the disease says 97% positive of the time when the person has the disease, yeah, and tests negative 95% of the time when they don't have the disease. So that's going to be 0.95 down there. 0.05 there. Right. Oh, find the probability that the person actually has the disease. Right. Oh no, hang on. Let me start it off. So if a randomly selected person tests positive for a diagnostic test, what's the probability that they actually have the disease? So that's the probability that they have the disease, given that they tested positively. So if a random sample, so reading the line again, if a randomly selected person tests positive for a diagnostic test, what's the probability that the person actually has the disease? So they've got the disease, given that they tested positive. So that will be disease and positive over probability of being positive. Right, so disease and positive out of being positive. So positive can come from this branch, which is 0.02 times 0.97. But being positive can also come from the third branch down, 0.98 times by 0.05. So I've got the disease positive, and then out of just being positive. So if I stick that in my calculator, it comes out as 0.2836 there. So that's fine, that is the probability. The pack goes on to work out the percentage. So I suspect at some point we'll change the word percentage to probability in question. I think that's it. My head's puzzled. It's time to go. So you got some questions to have a go at. See you later. Bye bye.